Ever looked at your car's dashboard and seen miles per hour? Then glanced at a ship's bridge display and seen knots? It seems a bit old-fashioned, right? Why don't ships and planes just use miles per hour like the rest of us? Well, the answer isn't just about tradition. It's a fascinating story that ties directly into the shape of our planet. A knot isn't just a random unit of speed. It's a mathematical link to the Earth itself, a language of navigation that's just as relevant today as it was for sailors centuries ago. So, let's unravel the mystery of the knot and discover why it's the ultimate unit for global travel. The story begins in the 17th century, long before GPS or even reliable clocks. Imagine you're a sailor in the middle of the vast ocean. How do you know how fast you're going? The solution they came up with was genius in its simplicity: the chip log. Sailors would toss a weighted, wedge-shaped piece of wood, called the chip, into the water. This chip was tied to a long rope with knots tied at very specific, regular intervals. As the ship sailed forward, the rope would unspool behind it. One sailor would hold the rope, feeling the knots pass through their fingers, while another would flip a 28-second sandglass. They would count how many knots on the rope unspooled before the sand ran out. If 7 knots passed by, the ship's speed was 7 knots. It was a direct, physical measurement of their journey through the water. This simple but brilliant method gave birth to the unit of speed we still use today. So, where does the math come in? Why not just convert those knots 2 miles per hour? This is where the knot's real elegance comes into play, and it's all about geography. The world is a sphere, which we map using lines of latitude and longitude. A circle has 360 degrees. Each of those degrees is divided into 60 smaller units called minutes of arc. A nautical mile is defined as exactly 1 minute of arc along any of Earth's meridians. So, if you travel 1 nautical mile, you have moved precisely 1 minute of latitude across the globe. This makes navigation incredibly straightforward. A statute mile, the kind we use on land, is based on Roman measurements and has no direct relationship to the planet's geometry. When you're plotting a course across thousands of miles of ocean, using a unit that perfectly aligns with your navigation charts is not just easier, it's essential for accuracy. This connection to global geometry is also why aviation adopted the knot. When airplanes first started making long-distance flights, especially over vast stretches of water, pilots were basically flying blind without landmarks. They relied heavily on the same principles of navigation that sailors had perfected over centuries. Using maritime charts and calculations based on nautical miles and knots was the most logical and consistent way to navigate the globe. This system allowed a pilot in London and an air traffic controller in New York to speak the same language of speed and distance, a language based on the fundamental shape of the Earth. As aviation became a global industry, standardizing on the knot ensured that everyone, everywhere, was on the same page, eliminating confusion and enhancing safety for international flights. It's a system that works perfectly, whether you're at sea level or 30,000 feet in the air. So, from a simple wooden chip and a knotted rope tossed into the ocean, we get a unit of measurement that has survived into the age of GPS and satellite technology. While your phone can now tell you your speed down to the decimal point, the underlying system that organizes global travel is still based on that elegant link between distance and the Earth's own dimensions. The knot isn't just a relic of the past, it's a testament to human ingenuity. It remains the most precise and logical way to measure speed on our spherical world, connecting the ancient sailor to the modern pilot. It's a beautiful reminder that sometimes the old ways are still the best ways. Thanks for watching, and if you enjoyed this journey through history and science, be sure to like and subscribe for more.